In this video, we'll introduce the basic concepts around blood pressure, resistance, and flow. And over the next few videos, we'll go into it in much greater depth. But let's start with some basic terminology. So when we look at blood supply, there's two terms that come up. One is flow and one is perfusion. So let's take a few minutes and define what they are. So when I talk about blood flow, I'm talking about the amount of blood going through an organ or a tissue or a blood vessel in a given amount of time. And look at the units. We're looking at milliliters per minute. Now there's a second term, and this term is perfusion, and it does have a different meaning. That at first they seem the same, but there's a key difference. Perfusion is the flow per given volume or mass of tissue in a given amount of time. So look at the units. Once again, we're looking at milliliters per minute per gram. So the concept and the definition of perfusion is much more exacting. Now at rest, total volume is quite constant and is really equal to the cardiac output of that moment. Let's talk a bit about blood pressure, or BP. Now, blood pressure, as the name indicates, it's a pressure. So this is the force that's exerted against the vessel wall. And we typically measure blood pressure and at the brachial artery on the left side. So we get a close approximation of the pressure at the exit of the left ventricle. Now, in past chapters, we've used these terminologies when we talked about the heart, but let's remind ourselves when we're looking at the two pressures that are recorded. We have systolic pressure, which is the peak arterial blood pressure taken during ventricular contraction, aka ventricular systole. And of course, the other measurement is diastolic pressure, which is the minimum arterial blood pressure taking during ventricular relaxation or diastole. And if you just sort of want a typical, average blood pressure of, would be somewhere in the range of 120/75 millimeters of mercury for a young adult. But as we'll see, as we go through the next few videos, blood pressure can be modified quite a bit, and it does change moment to moment, depending if you're sitting, standing, walking, whatever's happening in that moment in the day. There are a few more terms to look at. One is pulse pressure. And pulse pressure is the difference between systolic and diastolic pressure. Now, this is a good measurement to take because it gives you an idea of what is the pressure that's the driving force on circulation, and also gives you some indication as what's the stress exerted on the small arteries by the pressure surges generated by the heart. Another term would be mean arterial pressure, MAP, M-A-P. And there's a few ways to calculate this, but one way is a diastolic plus 1/3 of the pulse pressure. And what this does is it gives you a snapshot value of the average blood pressure that most influences basically risk levels for a number of conditions like edema, fainting, atherosclerosis, kidney failure, or aneurysms. Now, of course, blood pressure varies throughout the cardiac cycle, and accordingly, the blood flow in the arterial system will not always be constant, especially the closer you are to the heart. So what we see is we tend to get speed surges in many of the blood vessels, and basically the flow is pulsate. And to give you some values, some rough values, it could be from 40 centimeters per second to up to about 120 centimeters per second in terms of its travel through arteries. And of course, this is what accounts for if that artery is opened, you get the pulsate or the blood spurts that occur. Now, once we get to capillaries and veins, we see that the blood flows at a much more steady speed. And therefore, not surprisingly, bleeding from veins tends to be slow and steady. Now, there's a number of things that can affect blood pressure throughout one's life, but one of the things is aging. That atherosclerosis causes a hardening or stiffening of the arteries. And in that case, you lose some of the elastic tissue within the arterial walls. So you cannot mitigate those high pressure surges as well. The other thing is, so we also have, that was arteriosclerosis, I should say, arteriosclerosis. Atherosclerosis is the actual buildup of lipid deposits that become plaques. Now, this diagram we're going to have a closer look at in the next video, but I'll give you the basic rundown on it. Is we're looking at how pressure changes as we go from near the heart and from the large blood vessels to the capillaries, to the venules, and back to the vena cava. And you can see there's two overall trends. One is that the overall average blood pressure, the systolic and diastolic, goes down the further we travel away from the heart. And you can also see that the systolic and diastolic pressures get closer to each other as we move further away from the heart. And in the next video, we'll go over the causes of that.